All right, let's move on to the next section, which is going to be components. Now, in this section, we're going to want to drill down into a few of the core components that we saw previously in the Kubeflow architecture diagram. Specifically, we're going to look at the central dashboard, notebook servers, Kubeflow pipelines, KF serving, or what is now known as KServe, KDIB, training operators, as well as a quick look at the multi-tenancy capabilities inside of Kubeflow. All right, let's get started with the central dashboard. The central dashboard is going to be a browser-based UI that's going to give you visual access to a variety of different Kubeflow components that you see listed on the left-hand side there of our screenshot. Now, that's not to say that many of these components don't have SDKs, sometimes multiple SDKs, because they do. But for all intensive purposes, most folks are going to get started using the UI to navigate the different components. Because a picture is worth 1,000 words, let's do a quick demo of the central dashboard so we can understand how to navigate through it. All right, starting from the AWS console, we're going to want to connect into our minikf instance. Assuming you've already installed it, you want to type in minikf. This is going to give us a splash screen. Within the splash screen, we're going to want to take note of the URL as well as the credentials, as those are the ones that we're going to need in order to log into the central dashboard. Well, so with that information, we're going to be brought to the home page of the central dashboard, and this is going to serve as your central hub from where you can access recent resources, active experiments, as well as quick links to useful documentation. Under notebooks, this is where we're going to manage our notebook servers. You can see I've got a few deployed already. Under tensor boards, this is where we're going to manage our tensor board servers, as the name implies. Under models, this is where we're going to manage any KF serving or KServe models that we've deployed. Under snapshots, this is where we're going to manage our ROC-based snapshots. This is going to be specific to minikf deployments, more on that in a bit. Under volumes, this is where we manage our volumes associated to our cluster. Under experiments AutoML, this is where we manage our KDIB experiments. Under experiments Kubeflow pipelines, as the name implies, this is where we manage our experiments. Under pipelines, this is where we manage our pipelines. Under runs, this is where we're going to manage all of those pipeline runs that we might have executed. Under reoccurring runs, this is where we manage any runs that we've scheduled to occur on a reoccurring basis. Under artifacts, this is where we're going to track ML metadata or MLMD artifacts. Under executions, this is where we track various component executions in MLMD. And then finally, under manage contributors, this is assuming that you've done a minikf install. It's going to be single user, but if you've done a generic Kubeflow installation, then arguably from here, you're going to be able to configure user access sharing across namespaces. All right, the next component that we want to talk about is going to be Jupyter Notebooks. Now, Jupyter Notebooks are an open source, web-based environment for creating Jupyter Notebook documents. Now, these documents are going to be useful in interactive data science and scientific computing across a variety of different programming languages. Now, these JSON-based documents are going to follow a version schema. They're going to contain an ordered list of input and output cells, and these cells can contain code, text, markdown, math, plots, and even rich media, as we'll see in some of the examples that we'll see coming up. Now, you do want to note that the term notebook can refer to the Jupyter Web Application, the Jupyter Python Web Server, or the Jupyter document format. So you just want to be careful when you encounter it, what precisely is being meant when we say notebook. Now, how do Jupyter Notebooks manifest themselves inside of Kubeflow? So the Kubeflow Notebooks web app enables you to spin up Jupyter Lab notebook servers. Now, these servers can contain multiple Jupyter notebooks, but it's more common to see a one-to-one mapping. And not always the case, but more common, you're going to see this one-to-one mapping. Now, Jupyter Notebooks are going to also easily integrate with a lot of enterprise authentication and access control mechanisms, which is, again, is going to make them appealing. Now, you can create notebook pods and servers directly in the Kubeflow cluster, and you can do this by using images oftentimes that are going to be provided by your admin. You can also easily submit single node or distributed training jobs versus having to get everything configured on your laptop when you leverage a notebook. All right, so let's see Jupyter Notebooks in action. All right, so the first thing that we want to demonstrate is how to create a new notebook server. So you're going to want to go to the notebooks item in the Explorer tree. The first thing to do is to give your notebook a name. In this case, we're just going to call it Demo3. We're going to take all the defaults except you do want to add a data volume. And once you've done that, you're ready to go ahead and click the launch button. So a couple of seconds later, your notebook server should be online. At that point, you can click on the connect button. And because most people are going to be working through these courses in the context of tutorials, we're just going to go ahead and grab an existing data set and data files. And we can do that by clicking on the terminal button here within Jupyter Notebooks and then specifying where we want to retrieve that data file from. And once we have it, we can just navigate to it. You can see me navigating to it in the Explorer tree in the file directories. Find the Jupyter Notebook file that we want, open it up, and now we have the Open Vaccine tutorial. Okay, next up, let's try one different thing, which is going to be let's build a notebook server based on a snapshot. So I've already created a few snapshots using Rock. So now I'm navigating to where that snapshot is, selecting it. You can see I've brought it into that notebook server creation screen. I'm going to go ahead and name this notebook server. In this case, we're just going to call it Demo33 snapshot. And again, it's based on a snapshot of a previous notebook. We click the launch button. Once it's available, click on the connect button. It's just how we saw before, except all the data is already going to be loaded in there for me, plus any changes that I might have made prior to taking that snapshot. And that's how you can create new notebook servers. Next, let's talk about Kubeflow pipelines. So Kubeflow pipelines, or sometimes you'll see it abbreviated as KFP, is a platform for building and deploying portable and scalable ML workflows. Kubeflow pipelines is going to consist of a UI for managing training experiments, jobs, and runs. It also includes an engine for scheduling multi-step machine learning workflows. There's two SDKs that you can work with right now. There's a stable SDK for defining and manipulating pipelines and components. There's also a SDK that's a version 2 that's currently in beta that supports not only what the original SDK supports, but also adds support for tracking pipeline runs and artifacts using ML metadata or ML MD. Let's go ahead and see Kubeflow pipelines in action. Okay, now a quick word about workflow executors. So Kubeflow pipelines workflow engine runs on Argo workflows. Argo Workflows is an open source workflow engine for orchestrating parallel jobs on Kubernetes. It's a process that conforms to a specific interface and performs actions like monitoring pod logs, collecting artifacts, and managing container lifecycles. Now, as a Kubeflow user, we're going to need to pick a workflow executor. Now, the executor that we choose is either going to be Docker or Emissary based, which is new in 1.4. Now, why would you choose one over the other? Well, you'll want to choose Docker if you're intending on going to production very soon. Now, the thing to note here is that this is going to be deprecated in an upcoming Kubernetes release. Now, you'll want to choose the new Emissary executor if backwards compatibility doesn't matter to you and you need future proofing. So just a thing to note when you go about selecting your workflow executor. Next, let's talk about KF serving, or what is now known as Kserve. Model serving is just the simple act of making a machine learning model available for others to use. And by others, we mean probably a service or an application. As I mentioned, Kserving is now known as Kserve, and it's now been spun out as its own standalone project. So you may see those terms in the documentation being used interchangeably or not updated, but just for all intensive purposes, be aware that KF serving is Kserve, Kserve is KF serving. Now, what KF serving does in the Kubeflow platform is that it provides a Kubernetes custom resource definition, or a CRD, for serving machine learning models on a variety of different frameworks. And these frameworks can include things like TensorFlow, XGBoost, PyTorch, etc. And what KF serving does is that it helps to encapsulate many of the complexities that you would find with auto scaling, managing networking, health checking, and server configuration. Let's back up a little bit and get a little bit more color around what exactly is a Kubernetes CRD. So custom resources are extensions of the existing Kubernetes API. So by default, a resource is an endpoint that's going to store a collection of API objects of a certain kind. For example, the built-in pods resource contains a collection of pod objects. A custom resource is what's going to make customization possible in an otherwise default Kubernetes installation. So you can start to imagine why this is going to be very useful in something like Kubeflow. Custom resources let you store and retrieve structured data. So when they're combined with a custom controller, custom resources do create a truly declarative API. And a declarative API is what's going to allow us to declare or specify a desired state. And it's also going to help try keep the current state of the Kubernetes objects in sync. So what does this mean in regards to Kubeflow? Kserve and Argo workflows are going to be examples of CRDs. Now, what are ML frameworks? We touched on it in a previous slide. So machine learning frameworks are going to be things like TensorFlow, which is an open source library for machine learning that is an excellent choice for training and inference in regards to deep neural networks. XGBoost, which is an open source library that provides a scalable, portable, and distributed gradient boosting library. Scikit, which is a free machine learning library for Python. PyTorch, which is an open source machine learning library used in applications like computer vision and natural language processing. And then Onyx, which is an open format built to represent AI-focused machine learning. The next component we want to talk about is going to be KDIB. And KDIB is what's going to provide automated machine learning, or what's often called AutoML in Kubeflow. So like KF serving, KDIB is going to be agnostic to the machine learning frameworks. Think PyTorch, think TensorFlow. And what KDIB allows us to do is to perform hyperparameter tuning, early stopping, and neural architecture search written in a variety of languages. So if we rewind a little bit, what exactly is AutoML? So automated machine learning is what enables non-data science experts to make use of machine learning models and techniques and apply them to problems through automation. That's the big thing, through automation. So the sort of tasks that AutoML seeks to dramatically simplify are going to include data preprocessing, feature engineering, feature extraction, feature selection, algorithm selection, and hyperparameter tuning. It doesn't hurt to quickly touch on what a hyperparameter is for folks that aren't super versed in this nomenclature in machine learning. First, a hyperparameter is going to be external to the model, whose value cannot be estimated from the data, and it's going to be used in processes to help estimate model parameters. It's specified by the data scientist, it can be set using heuristics, and it's going to be tuned for a given predictive modeling problem. So a few examples is the learning rate for training a neural network, also known as early stopping, the C and sigma hyperparameters for support vector machines, and the K in the K nearest neighbors. Now, what is a neural architectural search, you may ask? It's a technique for automating the design of artificial neural networks. It's used to design networks that are on par or can oftentimes outperform hand-designed architectures. They're categorized according to the search space, search strategy, and performance estimation of the strategy used. They are closely related to hyperparameter tuning and are a component of AutoML. What is early stopping? Now, there is a challenge in training a neural network long enough for it to learn the mapping, but not so long that it overfits the training data. Now, one way to accomplish this is to train on the training data set, but to stop the training at the point when performance on a validation data set starts to degrade. In the world of training neural networks, this is what is known as early stopping. And you want to remember these are all components of AutoML. Now, let's go ahead and see KDIB in action. All right, in this really quick KDIB demo, we want to show three things. One, how to view experiments. Two, how to set up experiments two different ways. And three, how to identify the best run given our objectives. So the first thing we'll do is we'll orient ourselves. We're in the central dashboard. You notice that there's two links in regards to experiments. There's experiments Kubeflow pipelines, and there's experiments AutoML. This is the one we want to focus on in regards to KDIB. You'll notice that I've got 3 experiments already loaded in the UI, 2 are completed, and 1 is actually running. So if you're going to set up a new experiment, Kubeflow offers a new experiment wizard. So from here, you're going to just fill in relevant information in regards to metadata, trial thresholds, objectives, algorithms, early stopping if that's being leveraged, hyperparameters, and then we'll wrap up our trial template here by just putting in some dummy values. And once you get that done, you click the create button and you'll see the experiment in the UI. Now there's another way to go about it, which is preferred for me, which is that we're back in the Jupyter Notebook. We're going to enable the Kale add-on, and we're going to enable CATIB jobs inside of Kale. And it gives us the same sort of functionality in regards to control over the experiment. Plus, when we click the compile and run button, not only does it take my notebook, turn it into a pipeline run, but then it also runs the CATIB job for me as well. So you can see that's in the experiments view now, and you can see this is the experiment as it's running in real time. If we come back to the experiments view, let's double click on one that's already completed. And you can see here, I go look where the best trial performance is. It shows me which one it is. I can click on it and actually get the pipeline information as well. Okay, next up are training operators, and some of these are going to look pretty familiar based on some of the presentation that's already been delivered. Now, in Kubeflow, you train machine learning models with operators. With the 1.4 release of Kubeflow, all but the MPI operator have been consolidated into a single unified training operator. There are currently 5 operators that are supported. They include TensorFlow training, PyTorch training, MPI training, MXNet, as well as XGBoost. Now, a quick word about multi-tenancy. So multi-user isolation was introduced in Kubeflow 1.3. Why is this important? Well, in a typical machine learning production environment, the same pool of often expensive and sensitive resources are going to need to be shared across teams and users. So admins need to isolate users and their resources so they don't view or change each other's resource allocations. So the sorts of features that you're going to get right now with the multi-tenancy capabilities are going to be roles, which is going to be in admins and users, profiles, isolation, authentication, and authorization.